Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Bongani Mabuya and I will be with you throughout this lesson. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Today, we are going to tackle electrodynamics. That is the topic of the day. Electrodynamics. It is an extension of electric circuits. It's just that now we are putting the practical component of electric circuits. We are bringing electric circuits to life. So when we talk about electrodynamics, this is not a big term. We are just simply referring to electrical machines. So that's what we'll be dealing with throughout this lesson. I want us to look at the lesson objectives for the day. What is it that we'll be learning today? We are going to state the energy conversion in generators. We are going to use the principle of electromagnetic induction to explain how generators work. We are going to explain the functions of the components of AC and DC generator. We are going to explain the energy conversion of a motor. State the advantages of using AC over DC. Sketch the graph of AC and DC. Define VRMS. Define IRMS and solve problems. All of this, it is true or it is evident in the CAPS document in conjunction with the exam guideline of 2021. Everything that we do, we must always link it to the exam guideline of 2021. Why? Because the examiner will assess the aspects that are indicated only on the exam guideline. Now, the prior knowledge in grade 10, you did magnetic fields, and also you were in a position to conclude that like charges repel and like charges they attract. And then grade 11, you went on to do electrostatics, in particular the magnetic field and drawing of the field patterns, that the electric field patterns, they move from a positive charge to a negative charge. Furthermore, you did electromagnetism in grade 11, where you were looking at Faraday's law, because this law is very important to the topic that we are revising today. Faraday's law, where you have to express the formula as EMF is equals to -10 over the rate of change of magnetic flux through it. Then now in grade 12, we are saying that let's link this abstract content to what people are exposed to, which are machines. So we are going to talk about two types of machines. The first one, it is the generator, and the second one, it is the motor. In the exam, you'll be asked about a generator or a motor. I'm going to give you a minute to respond to this baseline assessment. So the question is saying, which additional movement of the bar magnet will produce the same deflection on the ammeter? And the correct answer there, we did say that we don't just choose, but you must eliminate the obvious distractors. You'll be left with two options. From those two options, you choose the most correct answer. Now, let's speak to the exam guideline, because everything that we do, it must link to the exam guideline. Our exam guideline is our point of reference. What does it say about electrodynamics? Number one, it says that we are going to state the energy conversion of generators. And for us to win here, if we can know generator, we'll know the motor. And most of us were exposed to generators, particularly during a period of load shedding, because we would use a generator when we don't have electricity in our households. So one thing that comes to your mind is that we use a generator when we don't have electricity to produce electricity. And for a generator to function, there is a rope or a rod that you must pull, and that rod, when you let it off, it is going to rotate. That rotation is the one that converts mechanical energy to electrical energy, because we use a generator to produce electricity. So the energy conversion of a generator is from mechanical energy to electrical energy. Furthermore, it says we must use the principle of electromagnetic induction to explain how a generator works. That's what we're going to deal with. Number three, it says we must be in a position to list and also provide functions of the components that we find in AC and DC. States the examples of the uses of AC and DC generator. Then we move to the motor. Then motor, we must state the energy conversion. A motor can be a hair dryer. Why a hair dryer? Because we need that turbine to rotate so that we can blow our hair. But for that turbine to rotate, we must connect it to an electric socket. So the energy conversion there is clear. It's from electrical energy to that rotation, which is mechanical energy. Then we'll look at the use of motor effect to explain how motors work. State the use of the motors. So that is what the exam guideline is saying. It's telling you that as you study, these are the things that you must cover. As we embark on revision programs, these are the aspects that we must touch when we deal with electrodynamics. Furthermore, must state the advantage of using AC over DC. This is what the exam guideline is saying. It's not saying DC over AC. It is saying AC over DC. Then we're going to sketch the graph of current versus time, of voltage versus time for both AC and DC. Then we are going to define the term RMS for alternating voltage and also RMS for current. So you can define RMS potential difference as, that's what the exam guideline, it is telling you that if the examiner asks you to define this term, you should be in a position to provide a definition that comes from the exam guideline of 2021. So RMS potential difference is defined as an AC potential difference which dissipates the same amount of energy as an equivalent DC potential difference. Then you must define current RMS. RMS current is the alternating current which dissipates the same amount of energy as an equivalent direct current. So the examiner is saying that these are the definitions that you can expect. So in question 9, electrodynamics, we can expect two definitions. It's either we define VRMS, potential difference RMS, or RMS current. Then we'll solve problems using the formula IRMS is equals to Imax over root 2, or VRMS is equals to Vmax over root 2. Then you can also include your power formulas. But what I wanted to emphasize here, it is the issue of subscripts. If you don't put the word RMS, then you must know that that formula will be marked wrong, the substitution will be marked wrong, even your correct answer will be marked wrong. Wrong formula, wrong everything. So let's make sure that we copy the formula the way it appears from the exam guideline, and also the way it appears from the data sheet. Because the use of a formula, it's a skill. So you must know which formulas to choose when you deal with question 9, electrodynamics. Which formulas to use when you are dealing with electric circuits. So for electrodynamics, we're including this subscript, small RMS. So when we talk about electrodynamics, I have alluded to you that it deals with machines. This topic is about machines, and for grade 12, we are limited to 2 machines, a generator and a motor. And from our previous lesson, I did say that if you are confronted with a comparison, it is best that you know one side so that you know that the other one, it is the opposite. So if we deal with generator, then you know that, oh, the motor is the opposite. So this topic, it deals with 2 machines, a generator and a motor. Then they'll ask you in the exam, write down the law that is applicable. When they say write down the law that enables these electrical machines to function as rated, it is Faraday's law. So when they say write down the law, your answer should be Faraday's law. And for grade 12, you won't be required to state Faraday's law, but from time to time we'll refer to Faraday's law. But when they say principle, that's where things change. If we are dealing with a generator, then the principle at which a generator functions with, it is electromagnetic induction. So this one is for the generator. But a principle for the motor, it is going to be motor effect. So when they say law, we know our answer. It is Faraday's law. But when they say principle, that's where our story changes. If we're dealing with a generator, it's electromagnetic induction. If we're dealing with the motor, it's motor effect. So let's compare the 2. And for us to understand them better, we must know what makes them different. A generator. When we talk about a generator, we are saying the energy conversion. Remember the exam guideline, it says you'll be required to state the energy conversion. So a generator converts mechanical energy, that rotation, into electrical energy. Then you know the motor is the opposite. So when we compare, that's what we must look at. Another thing that we must look at is in the exam, how do we identify a generator? How do we identify a motor? Now, a generator has an external circuit. So if you see an external circuit, you must know we are dealing with a generator. If you see a DC source, which is a battery, you must know we are dealing with a motor. Somebody say, oh, wow, wonderful. So that's how we identify whether we are dealing with a generator or a motor. A generator will have an external circuit. A motor will have a battery. When you see a battery, you know it's a motor. If you see a circuit, a light bulb, you know that is a generator. So To determine the direction of the current for the generator, we use Fleming's right-hand rule. That's what we're doing in grade 11. To determine the direction of a motor, we use Fleming's left-hand rule. Then the uses of a generator: to charge batteries. Motor, we find them in the latest editions of cars that we have in this world. What we call hybrid vehicles, where you go and charge your car. So in the future, matters of petrol will be very limited, because we'll have to go and recharge your car for your car to function. So that is a motor effect, because we convert electrical energy to mechanical energy to move the car. So now here is the question. When you look at this diagram, is this a generator or is this a motor? Just look at this diagram. What is it? Is it a generator or a motor? And your answer is clear. This is a generator. Remember we said if there is no DC source, then it is a what? A generator. We're having an external circuit here and the light bulb. So this is what? A generator. So how do we see that we have a generator or a motor? A generator has an external circuit. There's this, you'll see it with the light bulbs. So it has an external circuit. And then a motor has a DC source, which is a battery. Now, let's look into this. When you look at this diagram, is it a generator or it is a motor? Just look into it. Is it a generator or a motor? So, your answer is very much good. It is a motor. Why is it a motor? Because of the presence of the DC source. So here we call a battery a DC source. Now, let's continue then. Then, I want us to focus specifically on generators. Remember I said what is happening on generator is also happening on motor. The only difference is the energy conversion and the principles at which they function with. So when we talk about a generator is divided into two. We have what we call an AC generator and we have what we call a DC generator. Now, when you don't have electricity, you use a generator. But a lot of us were having a misconception to think that it is the petrol that produces electricity during load shedding or load reduction. And that is not the case. What produces electricity? It is the rotation. Now, let's use the principle of electromagnetic induction to explain what we mean by that. So inside the generator, there are two magnets. The other one is North Pole, the other one is South Pole. They're facing each other. And then the space between the two magnets, we call it magnetic field. It's a region of space in which magnetic object will experience a force. And then what will happen? In between that, we are going to put a coil. This coil will then be attached either to a slip ring or a split ring. So that's what I want to conscientize you with. Here is a generator. So inside the generator, we're having two poles. And then the space between the two magnets, we call it magnetic field. It is a B. We call it magnetic field. And then A, we call it the area of the coil. Right. So, in this magnetic field, we are then going to place the coil. And then we're going to have the area of the coil. You can see the area of the coil. Then what will happen is that this area of the coil, it will be connected to these two things, these complete circuits. Now, these complete circuits are the ones that determine whether we are having an AC generator or we are having a DC generator. So if you are going to have this component called a slip ring, then it means you are going to have an AC generator. And the word slip, it means it is a complete ring. So if we are having a complete ring, then you will have what you call an AC generator. And this ring will be attached to a stationary carbon brush and connects to the external circuit. So when you pull the rope from the generator and then you let it off, you cause the coil to rotate. When the coil rotates in the magnetic field, we are going to have an interaction of magnetic field and the area of the coil. And this interaction, it is called magnetic flux. It is expressed as BA cos theta. So as you release the rod or the rope from the generator, you cause the coil to rotate in the magnetic field. The more the coil rotates in the magnetic field, Faraday's law, it says that the induced EMF, the produced EMF, it is directly proportional to the rate of change of magnetic flux through it. So the more this coil rotates in the magnetic field, it is the more it is inducing the EMF. It is the more it is producing the EMF. And then we put in Ohm's law that says that the potential difference, the induced EMF, it is directly proportional to what? To the current in the conductor at constant temperature. So the more you induce the EMF, you are also producing what? The current. That is why you end up having electricity. So a generator will have two magnets and have a magnetic field between them. The magnetic field lines, they move from north to south. It is very important because it serves as a clue as well in the exam. The magnetic field lines, they move from north pole to south pole. And then the coil will rotate between the magnets. This rotation will cause a change in magnetic flux. A change in magnetic flux will induce EMF. When we induce EMF, we'll induce current. Now, what makes a generator AC? What makes a generator AC is only one component. And the name of that component, it is the slip ring. It is a complete ring. So what makes generator AC? It is the slip ring. What is the function of the slip ring? The function of the slip ring, it is to allow the current to flow in different directions. So the slip ring is the one that gives the name of AC generator, because AC stands for alternating current. So for us to have the change in current, we must have this component called a slip ring. What is the function of the slip ring? To allow the current to flow in different directions. Now, I want us to look at this AC. It is not DC. This is an AC motor. Why is it an AC motor? Because we're having a DC source. We're also having a slip ring. These are the complete rings. So the more we rotate, the more we're inducing the current. The more we induce the current, the more we induce the EMF, the more we have induced magnetic flux. So this is an indication of an AC motor. Now, I want us to look at the graphs of AC, because now we are dealing with AC. Remember the structural component that makes an AC. It is a slip ring. And the function of the slip ring is to allow the current to flow in different directions. This slip ring will be attached to a carbon brush. The function of the carbon brush is to connect the external circuit. Now, when you look at an AC graph will forever be a sine graph. But now what is important, it is the position of the coil. Because the position of the coil, it tells you where your graph would start, from a minimum value or from a maximum value. So if your coil is perpendicular to the magnetic field lines, if your coil is perpendicular to the magnetic field lines, then we know that we are going to have zero magnetic flux, we are going to have zero EMF produced, we are going to have zero current produced. So if your graph starts at 0, it's an indication that the coil is perpendicular, because anything cos 90 is equals to 0. Anything cos 90 is equals to 0. So if the coil is perpendicular to the magnetic field lines, then we're going to have zero EMF, we're going to have zero current. And then as the coil rotates, that is when we're going to have an interaction of magnetic field through the area of the coil. What will happen to the EMF? The EMF will increase up until this point. Now, up until this point, at 90, this is where we are having the area of the coil which is parallel to the magnetic field lines. So when the area of the coil is parallel to the magnetic field lines, then we are going to have maximum flux, maximum EMF, maximum current. Then the coil will rotate up until again it is perpendicular to the magnetic field lines, which is here at 180. What will happen here? Scenario number 3, because it is perpendicular, we are going to have zero EMF. The coil will then rotate up until it is parallel to the magnetic field lines. Then that's when we're going to have maximum EMF. Then the coil will rotate up until it is perpendicular. Then we're going to have zero EMF. So maybe a question can arise: how many complete cycles are demonstrated from this graph? So for you to have a complete cycle, you must touch 5 turning points, where it is 0, 90, 180, 270, 360. So this becomes one complete cycle. Sometimes it does happen that your graph can start from scenario number 2, where the coil is parallel to the magnetic field lines. If it is parallel to the magnetic field lines, then you can have a situation like this. Then they'll ask you EMF, we can have time in seconds. How many waves are represented here? You count 1, 2, 3, 4, 5. So this is 1. Then 1, 2, 3. So this becomes 1.5 waves. So this becomes 1.5 cycle. Then let's come to DC. So now we've spoken about AC. We said it has a slip ring. What is important is what makes an AC. An AC has a slip ring. Now let's come to DC. We are going to apply the same principle of electromagnetic induction. 2 coils that are placed inside a generator. We are going to have a coil between the magnets, and then what will happen? We are going to allow the magnet to rotate. As the magnet rotates, we are having the change in magnetic flux. we are going to induce the EMF. As we induce the EMF, we are going to induce the current. But now, what is the difference between AC and DC? And the word DC means direct current. So, a direct current, it has one component that makes it to be a direct current, is that it has what you call a split ring, or what we call a commutator. So an AC has a slip, a DC has a split. So we take one ring and then we split it into two parts. So a DC generator has a split ring. What is the function of the split ring? It is to ensure that the current flows in one direction. So as we compare AC slip, DC split. Now, as you look at this commutator, here it is light blue. This makes it to be a DC motor. Why DC motor? Because it has a split ring. It has a split ring. What makes this motor? It is the presence of the DC source. So you can see as the coil rotates, it is going to induce the what? The EMF. It is going to induce the what? The current. But the difference here is that because we're having a split ring, it only allows the current to flow in one direction. Here is the graph of DC. So this is a one complete wave for a DC generator. What is important is the position of the coil. For you to sketch the graph, you must understand the position of the coil. So if the coil is I love this picture. If the coil is perpendicular, we did say anything cos 90 is 0. Then we are going to have 0 EMF, 0 current. As the coil rotates, then the induced EMF will increase up until scenario number 2. So this is scenario number 1. This is scenario number 2. This is scenario number 3. This is scenario number 4. This is scenario number 5. So as the coil rotates, the induced EMF increases up until the coil is parallel to the magnetic field lines. When the coil is parallel to the magnetic field lines, scenario number 2, what is going to happen? We'll have maximum EMF. Then the coil will continue to rotate and rotate and rotate up until it is perpendicular. Scenario number 3. When the coil is perpendicular, then we'll have 0 EMF. Then the coil will continue to rotate up until it is parallel. When the coil is parallel, then what will happen? We're going to have maximum EMF. Then the coil will rotate till it is perpendicular. So the difference between AC and DC is that DC rotates in one direction. If it rotates on the upper part, the positive side, it rotates there. If it rotates on the negative side, it rotates on the negative side. Because it has only what you call split ring, which allows the current to flow in one direction. Then, here is an activity. I'm going to give you 5 minutes to discuss it with your peers. We encourage what we call a peer collaborative revision program. It is more about the learner now other than the teacher. Learners, they need to recitate, they need to issue, they need to work, they need to put effort in ensuring that they prepare themselves well in advance for the upcoming examination. So The first question is saying, discuss 3 ways in which induced EMF can be increased. So one can say, increase the number of windings of the coil. The other one can say, increase the number of rotations. The other one can say, increase the magnetic field strength by bringing magnets closer together. So those are the 3 ways in which we can increase the induced EMF. The second question, discuss the advantages of AC over DC. And this is in the exam guideline. We must state the advantage of AC over DC. 1, it is easier and cheaper to convert AC to DC. Number 2, AC voltage can be stepped up or stepped down using transformers. And also we can transmit AC voltage over a long distance with minimal energy loss and low current. Then let's come to VRMS and IRMS. From the exam guideline, it defines these concepts clearly. What is VRMS? It is RMS potential difference. Sometimes they'll say RMS voltage. And the word RMS, it means root mean square. So what is RMS voltage? It is an AC potential difference which dissipates the same amount of energy as an equivalent DC potential difference. Let's make sure that we write definitions the way they appear from the exam guideline. The formula for VRMS is VRMS is equals to Vmax over root 2. So when we talk about IRMS now, which is current RMS or RMS current, the exam guideline clearly defines it as an alternating current which dissipates the same amount of energy as an equivalent direct current. Let's make sure that all our definitions, they emanate from the exam guideline. The formula IRMS is equals to Imax over root 2. Let's make sure that we write these subscripts. Let's make sure if we omit them, we lose all the marks for calculations. Here is a question. I'm giving you 10 minutes to respond to it. Now it is the feedback time. Let's look at the question. The graph below shows the output voltage from a household AC generator for 1 cycle of rotation of the coil. So you can see we're having 1 complete cycle. And they'll ask you a question. By merely looking at the graph, are we dealing with AC or DC? What will be your answer? It is an AC. It's an AC because the graph is a sine graph. 2.1. A 100 watts light bulb is connected to this generator and it glows at its maximum brightness. Use the information from the graph to calculate the resistance of the bulb. So the first thing that we must look at here is that we are given the voltage from the graph. But this output voltage, it reaches maximum state, which is 340 volts. So we can agree that here we're having what you call Vmax, which is 340 volts. We're given power, which is 100 watts. The question wants the resistance. So how do we deal with it? So I mentioned to you, we are given Vmax 340. We are given power 100 watts. Because we are having this Vmax, One learner can say, we can say VRMS is equals to Vmax over root 2. You can see we put the subscripts, RMS, max. Now, for us to get VRMS, we are going to say 340, which is our Vmax, all over root 2. Then VRMS would be 340 divided by root 2. Then our answer will be 240.42 volts. Then once you are having the VRMS, then you can say power average. If this average is not there, you lose the max. Is equals to V squared RMS. If this RMS is not there, you lose the max, over R. What is our power average? We're given it's 100 over, which is 240.42 squared over R. So 100 R is equals to, let's look at 240.42 squared. 240.42 squared. Right? I think it's going to give you 57,801.7764. Then you divide by 100, you divide by 100. Therefore, what is going to be our R? So we're going to say 57,801.7764 divided by 100. Then your answer will be 578.01 ohms. The next question is saying calculate RMS current. Then you can say IRMS is equals to VRMS all over R. What is our VRMS? Is 240.42 all over 578. So what will be our IRMS? And then I think our answer will be 0.42 amperes. So you get 3 marks. 1 mark for the formula, substitution, and the answer. Here for 5 marks, formula, substitution, and then 1, 2, 3. So that's how you get these marks. And you can see, if you write the correct formula and you substitute, you can be guaranteed maximum marks. Then, give one reason why AC is preferred over DC. It's cheaper and easier to convert AC to DC. Or AC voltage can be stepped up or down using transformers. Then, here is your homework section, of which you need to make sure that you do it and you discuss it with your friends. Because what is important is for us to learn from our mistakes, so that you know, where am I getting these things wrong? How do I rectify them? So this is your homework, and our next lesson will start from this homework. So the summary, we spoke about AC and DC generator. And we said that if they say write down the law that is applicable, your answer will be Faraday's law. But if they say principle for a generator, a principle, it's electromagnetic induction. The energy conversion is from mechanical energy to electrical energy. Next time, when we meet on our next lesson, be prepared that we are going to continue from where we left off. We are going to use past question papers to make sure that these concepts, they are embedded within us. Now, as I finish, It is in your hands to create a better world for all who live in it. We trust you as young scientists to provide future scientific solutions to all the challenges that the world faces. I wish you well. See you next time. Bye-bye.